All right, dude, we are live. What's up, guys? This is Dem Keys, and today we're gonna have a yap sesh. We are basically just gonna be doing just chatting. You know what? I should have probably been in the just chatting category, but like I decided to be in software and game development category instead, just in case maybe we might do some. Actually, you know what? We are doing research on like coding related stuff, so I mean, it's fine. Being in software and game development is fine. But yeah, what's up, guys? This is Dem Keys. Why did I just say this is Dem Keys again? What's up, guys? It's good to stream again. After missing streaming a couple of days, I think. The last time I streamed was 5 days ago, I think. The days kind of just got away from me, and I wasn't able to stream. And unfortunately, I also haven't been keeping up with my thing that I wanted to do, where every day I would dedicate at least 1 hour to sculpting, Blender sculpting. It's unfortunate, but it is what it is. I'm gonna try. I'm still gonna keep trying to keep that up. I hope the mic isn't having any interference in it. Wait, hold on. Are we live? Because my stream manager page didn't show. Give me a second. Let me just refresh the thing and oh yeah, we're live. So yeah, I've been busy, dude. For the past 3 days, I think I would say. Yeah, about 3 days, I think. Maybe 4 days. I don't remember. I've been working on this application. I wanted to make an application that could help people understand, help people visualize matrix multiplication calculations. So I made something to help with that. Let me just demonstrate it. Now, when I enter play mode, or more specifically, I think after I generate the matrices, things kind of slow down a little bit. So my VTuber avatar might start to lag. Just bear with it for a little bit, and then I'll exit play mode. So the way that this application works, I'm going to be releasing this to the public as well eventually, once I polish it up a little bit. It's a simple application. Basically, you just open up the app and then you click generate. Usually when you open up the app, then it generates at first run. It not first run, at how do I even say this? When you open up the app on startup, it generates two matrices for you. So you don't need to click generate the first time. But if you want to generate more, then yeah, you have to click generate. So when you click generate, it's going to generate two random matrices, matrix A and matrix B, and it's going to keep the rule in mind where an M by P matrix can only be multiplied by a P by Q matrix. What this means is that matrix A can only be multiplied by matrix B if matrix A's column count matches matrix B's row count. That's just how matrix multiplication works. That's one of the rules. And if that rule is not followed, then there is no multiplication defined between those two matrices. So you can't really multiply them. What was I? Oh, yeah. Okay. So once you start up the app, you have matrix A and matrix B generated for you. And then those two matrices will be multiplied. And the result, matrix C, will also be generated / displayed for you. Now, here's the cool part. You can step through the calculation for each of matrix C's cells. So you enable step through calculation, and then you have these arrows. You can see one cell gets highlighted here. You can step through the arrows to see each of the cells. You can also step backwards. I wanted to add that feature in case people wanted to, step back. and each time you step to a new cell, for that cell, it's going to show you the calculation that's taking place. And in this section, it gives you the entire equation used to calculate that. I also color coded some of the numbers to show, actually all of the numbers. I color coded the numbers to show which matrix they are from. This is a relatively simple matrix in terms of like cell calculation. So let me try showing you a more complex matrix. Something like, you know what? We could do this. Yeah, we could do this. So this is a good example. We generate this matrix and then we start stepping through the calculation, and then we can step through each cell to see how that cell was calculated. Eventually, I'm going to be releasing this to the public as well. That was the whole idea from the beginning. I wasn't just going to keep this to myself. Eventually, I'm going to release this to the public. I do need to make a video with this first, and after that, I'll be releasing it. I need to polish things up a little bit, not in terms of aesthetics, really, just mostly I need to do a bunch more testing to make sure there's no little bugs here and there. Like yesterday, I discovered, after testing it for a while, I discovered one bug where if there's only one cell in matrix C, so if it's a one by one matrix, if C is a one by one matrix and there's nothing to step through, then it's this arrow. When you start the stepping, this arrow would still be highlighted. So the way it's supposed to work is, so okay, we have 4 cells to step through here, right? But we are already on the first cell, so there shouldn't be any back, any like the user shouldn't be able to step back. So I have to disable this. I have to make it non-interactable. And then likewise, at the other end, when we are at the very last cell, we don't want the player to be able to, or user to be, I don't know if I've been saying player all this time. But anyways, we don't want the user to be able to step further from this because, you know, it's out of bounds. So I had to handle that calculation. But the way that I was doing that, I had to handle that logic. But the way that I was doing that, it didn't account for a single cell. Like if the entire matrix was just one cell and there was nothing to step through. So because of the way that I'd set up the logic, it was still providing that button. And if you hit the button, it would throw in. Actually, I don't remember. Was it throwing in an error? I think it might have been throwing in index out of bounds error, or maybe it just wasn't doing anything. I don't remember. Either way, it wasn't supposed to be there. Like it wasn't. The option shouldn't be available for the player to step if there's only one. So that's one example of the kinds of bugs that I'm trying to like get rid of, and that's also what I mean by, you know, polishing up the app. I need to iron out all the bugs and then make sure the workflow is fine. I don't think I'm going to change anything in terms of aesthetics. Maybe I might change the information in these two text sections. Oh, also, just as an added thing, I did add in functionality for unsigned numbers, just to show that, yeah, okay, we can also do unsigned numbers in this, just as an example. Dude, believe it or not, I wanted to have 3 options. I wanted to have um, signed integer, unsigned integer, and float. But because of the way that I've set up the code logic, that would have complicated things a little bit, because internally I have to set up a bunch of different data structures for various things. First of all, the matrices themselves have to have data structure. By the way, okay, this is great because this is probably one of the first projects that I've had in my more than a decade of C# programming. I think this is one of the few projects that I've had where I had to use a multi-dimensional array. I've almost never had to use it. If I had to use it in the past, maybe I've forgotten by this point. but like multidimensional arrays, it's just one of those things that never came up for me because usually there would be some other structure available to represent whatever data I was trying to represent in a multidimensional array. So I didn't really have a need for it. At most, I would do jagged arrays. I wouldn't do multidimensional arrays. But this was one of the situations where it quite literally needed a multidimensional array, and a multidimensional array was sort of the best fit for this situation because multiple dimensions, or more specifically 2 dimensions, accessing everything as if we are accessing how do I say this? Indexing. Yes, that's the word. Indexing the array as if we are trying to read specific cells of the matrix is possible if you are doing it as a multidimensional array. So yeah, internally I had to set up a bunch of data structures. First of all, for the matrices themselves, but also for various things like so each of these cells, there's a matrix for each of these cells as well, I believe. Then the cells in the background, you see the red color. So this is just like it's a raw image, a raw Unity UI raw image, and so you can set colors for this. You don't have to set a sprite. So I'm just changing the color of it. So I had to maintain, or I have to maintain data structures for all of the raw images as well. The great thing is I'm able to create the data structures in the exact order as the matrix, as each of the matrices, the respective matrices. And so I don't need to worry about ordering of the matrices or ordering of the data structures. So if I have matrix A, let me open up my VS Code to give you an idea. I'm not opening it up on stream, but like I'm just opening it up in the background. Oh God, I probably shouldn't have done that. Okay. Yeah, I just remembered that I wasn't supposed to keep this running for too long. Hold on. Right. So, just as an example, for matrix A, I have I have a multidimensional game object array. By the way, the way that I've set up this code, once I release this, I'm just going to put this out there. The way that I've done the coding for this is horrible. It is horrible for performance because there's a lot of like references being passed around here and there. There's most definitely instantiation and destruction going on because each time you click generate, uh, give me a second. Let me go back into Unity. Yeah, each time you click generate, each of these cells is a separate game object. It's a prefab that I've created, and that prefab has a has a text component and or well, it has a text game object and a raw image game object. So that's the prefab. I call it the cell prefab because it's one cell of the matrix, and each of these is a separate game object. Each of these cells is a separate game object that gets instantiated each time you generate a new matrix. I could have set up an object pool, but I figured for such a small thing, an object pool is kind of unnecessary. It would have added unnecessary complication because, dude, matrix A, let's say matrix A is a 4 by 4 matrix because that's the maximum, by the way. Yeah, you can only generate anywhere between 1 and 4 dimensions for the matrices. I didn't feel the need to have more. Did I say 1 and 4 dimensions? No, no. You can generate anywhere between 1 and 4 rows and columns, not dimensions. It's always a 2-dimensional array. So you can generate anywhere between 1 to 4 rows and columns, meaning at max you're going to have a 4 by 4 matrix. So let's say matrix A is 4 by 4, matrix B is 4 by 4, and the resulting matrix C is also 4 by 4. we're going to have what, 16, 32, and then what's next? 48, I think. Did I get that right? 16, 32. Yeah, that's right. So at most, we're going to have 40, 48 game objects. I don't know if, I don't, yeah, I'm not entirely sure if I need to create an object pool for that, because this is one of those things where it's not like we are constantly, instantiating and destroying, unless I'm doing something like this, unless I'm purposely doing something like this, where I'm constantly instantiating or I'm constantly generating a new matrix. I'm not going to be doing a whole lot of instantiation and destruction. So I didn't feel the need to have an object pool. That also means that because of the choices that I've made, there is going to be garbage collection every now and then. So there might be a small hitch. But this is one of those situations where I feel like we can avoid, not avoid, we can't avoid garbage collection, but we can ignore. That's the word I was looking for. And this is one of those situations where having a small hitch in the program is not a big deal, because this is just supposed to be a slideshow kind of program where you generate the matrix and then you start, or you generate the matrices and then you start stepping through the calculation. And then each time you step, you have values changing. It's not even like there's some kind of animation going on, which, by the way, I had plans for an animation. I had plans for how I wanted the calculation to show up. This is why it's very important to prototype what you have in your head for whatever project. I was about to say project again. Whatever project you have in mind, it doesn't matter. You have that idea. Write it write it down on paper. In the case of a game, it would be a game design document. Right. And in the case of this, I had just like a regular document to write down the notes. I had ideas for what kind of animation I wanted to do. I wanted to do something cool, like uh, each time we each time we step to a new cell, then each of these cells will sort of light up. It's not like right now where it's suddenly just, it's like a very sudden thing. You see this? Like, you see how red, it just seems like it's shifting. What I was going to do is fade out the color and then fade into like a newer cell. So basically dim this cell and then light up this cell. So gradually it would have been a whole, like, animation sequence. Each of these, for each cell, the thing would have lit up, and then an animation would play where the numbers would be taken from each of these things, from each of these cells, and they would be shown coming into this equation. So like I had that in mind, but that's not how it worked out. Like when I was implementing it, I realized that implementing that animation would have been too much of a headache, more trouble than it's worth. Let me just put it that way. It would have been more trouble than it's worth, and for the purpose that I'm for the purpose that I was building the app for, it wasn't really necessary. It would have been a nice added bonus, but it wasn't really a necessity. So I didn't want to waste time figuring out the logic for that. And so I decided to go with this instead. So I scrapped the quote unquote animation section of it, and I went with this instead. But yeah, going back to what I was saying in terms of like in terms of garbage collection, the logic that I've written is definitely going to cause garbage collection. And if you look at the code, which you will be able to once I publish the thing, you'll see that like there's a lot of sections where things could have been done in a better way, but I chose not to do it in a better way because the way that I was going for was the simplest at that time. Like in that moment while I was working on the project, it was the simplest thing to implement. So I went with that instead. it worked, so whatever, right? That's the logic that I was following. It's it may not necessarily be the best for performance, but this app that I'm making, I don't really give a shit about performance in this app, if I'm being blunt, because even if there is garbage collection happening, it's not often going to show up unless maybe, let's say, the user hits generate during a time where there is garbage collection happening. Then yeah, sure, there might be a little freeze for a couple of seconds, but it's really not a deal breaker because it'll take a couple of seconds, garbage collection will be over, and then there you go, player again, the user can then just continue with their simulation, this thing. They can generate the matrix, and they can start stepping through the calculation and then step through each of the cells. But yeah, I'm proud of this thing that I've made. I'm super happy because it kind of ties in to the deep learning stuff, because like in PyTorch, I have been exploring. I'd mentioned this before that. So in the examples, they in the tutorial section, they show you how to build a neural network, a very simple feed forward neural network, and then they also show you how to train that network, right? Let's keep the training aside for now. For now, let's just talk about the building of the network. They showed some functions, right? What I wanted to do is I wanted to dive into every single one of those functions. I wanted to understand what each of those functions was doing. And so I wanted to do those calculations like individually, outside of the context of the neural network, outside of the context of the bigger neural network, I should say. I also learned this. Apparently, there's this sort of architecture that PyTorch is expecting. I don't know about the more complex neural networks, but at least with feed forward neural networks, the kind of architecture that's being expected. I don't know if I should say specifically PyTorch related or not, but I'll explain why I have this thought process. I'll explain that after I explain what I was trying to explain just now. So you are expected to create a class. So like in terms of creating a neural network, you are expected to create a class, and that class derives from nn.module, and then in that you have your init method where you create a bunch of the fields, including the sequential field that's going to hold all of the neural network layers, and activation functions and all of that stuff, right? And then this is the important part. You need a forward method. You need to define a forward method. In that method, you're going to be doing your main calculation. You're going to be using these layers that have been defined. You don't call the forward method directly. That's the interesting part. You don't ever call. I mean, I'm not going to say ever. There might be specific situations, but like usually you don't call, and even the documentation says this. You don't usually call the forward method directly. It gets called when you call the neural network as a function. So it gets called internally. It gets called internally when you call the neural network as a function. Okay, so let's keep this aside. Okay, let's keep this in mind, but also keep this aside for a second. I was exploring Onyx. Onyx is a how do I even explain this? Onyx is a format that's been developed for representing machine learning models independent of whatever framework. So, as an example, you can create a feed-forward neural network in PyTorch and then export that to the Onyx format. That'll produce an Onyx file, an Onyx model. Well, it's an Onyx file that's representing It's an Onyx file containing the Onyx model that represents your model. So basically, your model has been converted into a bunch of Onyx operations. It has been represented in the form of Onyx operations. And then you can run this model in any environment that has an Onyx runtime. Of course, there are a few more like specifics. It's not quite that simple, but like that's the gist of it. There are a few more specifics here and there that you need to be careful of, but this is the gist of it. This is what makes Onyx powerful. It's that this allows you to run machine learning models that are built in different frameworks. You can run those models even without those frameworks. You can run them on different platforms. So a very good example is in Unity, we have Centis now, which I will be exploring more later on, a lot more later on. No, that makes it sound like I'll be exploring it like much later on. No, I mean I'm gonna be exploring this a lot more in detail later on. That's a better way to say it. Now, what was I saying? Yeah. So in Centis, you have Unity's implementation of the Onyx runtime, and because of that, you are able to run Onyx models in Unity through Centis. So this is one example. There's tons of other examples as well. Why was I talking about Onyx? Oh yeah, okay. So PyTorch has two ways to export your model to the Onyx format. One is using Torch script, and one is using something called the Dynamo. What's it called? I think it's called Torch Dynamo. And I've been looking into Torch Dynamo. I looked into Torch script as well, but I was more interested in Torch Dynamo. So I've been using Torch Dynamo to, or well, I tried using Torch Dynamo to export the model that I had built. So initially, what I was trying to do was I was just trying to export individual functions, but that didn't work. That was throwing an error. And then I tried building a class, a simple neural network class, the basic boilerplate code, which is the class or a class that inherits from nn.module, and then you have your init method, and then you have your forward method as well, right? You create an object of this class. Now, okay, also I should mention that that simple linear function that I was trying to export to Onyx, I placed that linear function into this sort of shell of a class or shell of a neural network that I created. And then I created an object of this neural network and passed that to the Dynamo export function. And then it worked. So from this, I gathered that, and this is why I was mentioning earlier, that apparently you are expected to follow a specific architecture if you are trying to use these various like exporting functions and stuff, or not even exporting functions. So I had one situation which was the exporting function. There are also other situations that I've seen where it is expecting you to follow a specific architecture or a specific workflow, so that it's able to do various types of optimizations. And in some cases also because certain functions are made with the assumption that you're going to be passing in a specific kind of, how do I even explain this? With the assumption that you're going to be passing in a neural network class, not just one simple, or well, a neural network class with a forward function, not just like a simple linear function. I don't know if I explained that very well. The funny thing is, using the Torch script exporter, I'm able to export to Onyx. I'm able to export that simple linear function to Onyx pretty easily. Oh, sorry, accidentally hit my what is this? My pop filter. Dude, I was supposed to eat I haven't eaten since I woke up, which was maybe 4 hours ago, almost 4 hours ago. So I'm yet to eat. But like I saw that I had a chance to stream, so I was like, dude, I don't want to miss this chance because I hadn't streamed in a couple of days. So I was like, dude, let's not let this chance go. But yeah, dude. Okay, so like I was saying, I've noticed this thing where you're expected to follow a specific architecture or a specific design to build your own architecture. Real quick, in the next like 10 seconds, there's going to be an ad playing. So I'm gonna start the ad break right now. I'll see you guys in 30 seconds. All right, welcome back. So, what was I saying? I was talking about Onyx, and I was talking about exporting stuff to Onyx. So I'm excited for this as well. At some point, we're going to be. Oh, that's also why I opened this thing up because I'm going to be reading up on Onyx. I'm not going to be going too deep into this. I absolutely do not plan on writing models in Onyx itself. But I do want to get an understanding because I'm mainly going to be using Onyx as an intermediate representation of the actual model. That's the idea. I'm going to use Onyx as an intermediate representation, and there are already converters that convert your entire PyTorch model into the Onyx format. So I don't need to learn all of Onyx. I just want to get some basic understanding of the concepts, which is why I'm going to be looking at this section, and then maybe I'll look a little over here and like, okay, so there's a first linear regression thing. I By the way, this suddenly just clicked for me a couple days back. Somehow it didn't occur to me previously, but like in the linear function of the simple feed forward neural network, it says that y is equal to x multiplied by a, which is the weight, plus b, which is the bias, and x is your input. I forgot to mention that. That is the exact same equation used for linear regression. Somehow that didn't occur to me, and I'm kind of glad that I kind of came, I guess we can say, full circle and came back to linear regression because this time I think I'm going to actually go all the way and fully understand. I mean, to be fair, we did understand linear regression previously. I just never did the practical side of it. I never finished practicing linear regression, so I still need to do that. There was also, okay, so there was there was like general linear regression, and then there was decision tree regression, which I need to look into as well. Because in the Kaggle course that we were doing, it used decision tree regression to solve a problem, right? But decision tree regression is different from just linear regression because it uses a tree sort of format. So I need to read up on decision trees as well. So there'll be a little bit to explore there. First of all, linear regression, but then also decision trees, and then decision tree regression. In terms of like just basic ML stuff, because dude, there's only so much. How do I say this? There's only so much time that I can give to, every single thing. I can't give time to every single thing. I have to kind of pick and choose what I'm going to be giving my time to. And currently, I'm giving my time to deep learning. So, machine learning itself, it kind of has to sit on the side. But I kind of want to do the machine learning side of it as well, because a lot of the techniques that you learn there, they do kind of, you are able to use them in your deep learning models as well. So I kind of want to learn both of them, and Kaggle is going to be my way of doing that. Well, at least learning machine learning. I think eventually Kaggle also goes into deep learning. It also goes into like neural networks and stuff. So I think eventually we're gonna like converge. We're gonna be doing, PyTorch meets Kaggle. Actually, I don't know if Kaggle is doing. I think Kaggle uses TensorFlow, but that's fine. I can convert. Like, I'm learning PyTorch. I think I'm going to be knowledgeable enough, or I mean, I don't even need to be knowledgeable enough in PyTorch. I can just find a way to do it, even if I'm not knowledgeable enough. What was I saying? Yeah, I'll find a way to convert whatever TensorFlow code they're writing to the closest possible version of PyTorch. By the way, dude, PyTorch, oh my god, it is such a bitch to install. Let me just put that out there. Motherfucker. It is, holy shit. First of all, massive fucking download, okay? But after that, I have to just leave the system alone for a good hour, maybe. I've had to install PyTorch on 2 different systems so far, and each time I had to leave it alone for a while. Dude, the first time I had to do it, I had such a hard time, but that was mostly because of a small confusion that I had. See, because I had an older version of PyTorch, and that didn't have the Dynamo export function. It wasn't using, they weren't using Torch Dynamo at that point. It was an older version of PyTorch in the project that I was using. So I had to upgrade PyTorch. I wasn't able to find like a less messy way of upgrading the project or upgrading the package. A lot of people were just saying, dude, just uninstall PyTorch and install the latest package. That seemed like the most straightforward thing to do. So I did that. The problem was I only uninstalled PyTorch, or I only uninstalled Torch. I didn't uninstall Torch Audio and Torch Vision, which are 2 additional packages that also get installed when you install PyTorch, because the PyTorch command, it mentions Torch, Torch Vision, and Torch Audio. So you're installing all 3 of them. You're not just installing PyTorch. So the first time I'd installed PyTorch, I'd installed all 3 of them, right? But uh, when I wanted to do this quote unquote upgrade, this update, I had to uninstall PyTorch. I forgot that I was also supposed to uninstall Torch Vision and Torch Audio. So basically, I had the old version of Torch Vision and Torch Audio, but I uninstalled Torch and tried to install the new version of Torch Vision and Torch Audio. No, I uninstalled the old version of Torch and tried to install the new version of Torch. But because I had the older versions of Torch Vision and Torch Audio, what ended up happening was it it went through the whole download process for the new Torch version. It downloaded it, it installed it, and then when it came time to install Torch Vision and Torch Audio, it found the old versions of Torch Vision and Torch Audio, and so it tried to install the old version of PyTorch again, which meant it had to download the old version, which was another fucking 2.7 GB. It downloaded that and installed that, and that just replaced the new install that I'd done. So that entire process was kind of a waste. And I was like, oh my god, what is going on? Then I found someone, similar who had, or somebody who had a similar issue to me, and then one of the people mentioned that, yeah, you have old versions of those two libraries as well, so you need to uninstall all three of them and then install all three of them again. And then I was like, oh, damn. Okay. So lesson learned, I guess. But yeah, even keeping all that aside, even if it's just like a fresh install and like an empty project, even then the install takes time. You have to leave the system alone. First of all, the download is going to take time unless you have a good connection, right? But after the download is done, you have to leave the system alone for a good like 45 minutes to an hour, depending on like, you know, what the performance of your system is. You have to leave it alone for a while. PyTorch takes a while to install, dude. Like holy shit. Okay, enough ranting about that. I forgot what I was talking about before I started ranting about fucking PyTorch installation time. What was I saying? Okay, I don't know. But yeah, so uh the the plan for me in terms of deep learning and Kaggle, or well, the plan for me in terms of studying, because um, once I'm done with this matrix multiplication thing, I'm super happy. I'm super happy with the way that this whole thing went down. Like I started learning PyTorch. I started breaking down each of the operations for creating a feed forward neural network. And then the very basic operation, which is the linear operation, which performs a linear transformation, that led me to relearning matrix multiplication. And that led me to making this application that I have. Shit, I forgot the application is running. And we've probably been having really horrible frame rate for a while. Holy shit. Yeah, let's turn this off. Uh, yep, things improved a little bit. Yeah, yeah. Okay. What was I saying? Yeah, so uh, I'm I wanna get back to the deep learning stuff. I wanna get back to PyTorch. I'm excited for that, and now it's gonna be much better because now I'm gonna understand the calculation that's going on. Um, there was also a slight confusion for me in between where like I had to do some research to understand why this is. Apparently, and this is for legacy slash optimization reasons. That's the best example that I have. It's for legacy, and for legacy slash optimization reasons. They transpose the weight matrix. So every node in, or every neuron in the linear layer has a weight matrix, right? So your input tensor gets multiplied by that weight matrix, which is also a tensor. But yeah, this is basically a matrix multiplication that takes place, and then the result gets added to it gets, or well, bias gets added to the result. Where was I going with this? Yeah, so apparently they transpose the weight matrix. So if you look at the PyTorch, or if you look at the nn.linear functions, give me a second. Should I search here? I think I have to search here. Right, here it is. So, um, if you look at this, it says applies an affine linear transformation to the incoming data. Y, which is your result, equals x, which is your input, multiplied by. Okay, guys, sorry for the abrupt end.